On the edge of space, halfway to the nearest star, there is a vast cloud of debris, lumps of rock and ice that have drifted on the edge of our solar system for 4 billion years. They are among the most mysterious objects in the universe. Sometimes they are sent into the heart of our solar system, where they are transformed into the blazing stars we call comets. For centuries, our ancestors were in awe of comets. They were messengers from the gods, carrying the power of life and death. It's only now, as we have the power to uncover the comet's secrets, that we are discovering that those ancestors were right all along. The comet's tale is a story that really can tell us about life, the universe, and everything. About once every 10 years, a really bright comet lights up the skies. Some are bright enough to be seen in broad daylight. Others unfurl their tails across half the sky. They appear from nowhere and just as suddenly disappear. It's little wonder that throughout history, people have tried to explain their significance and the effects they have on the Earth. As far back as the 2nd century BC, the Chinese had taken the trouble to classify comets into 29 separate types. The shapes they saw were so striking, they have penetrated human consciousness. Many other societies explain the sudden appearance of comets through their mythology. Comets mark the presence of gods in the skies.
Comets are recorded in myths globally. Almost every population in the world talks about dragons, things that fall from the sky, stones and iron that fall from the heaven, giants with a single eye in their head, and wizards and things like that that can be interpreted as comets.
If you look hard enough, comets can even be found in the most famous folk stories.
When you peel away all of the layers from the King Arthur story, what you're left with is a local lord who was left in Britain after the Romans had retreated. And that doesn't explain why or how he became such a huge figure in English folklore. There's another possibility, and this is that Arthur may have been a comet. When Arthur has a battle, he takes a sword out, and that sword shines with the light of 30 torches. And generally, Arthur's battles occur at times of known meteor showers. And in those battles, there's widespread destruction. In one of the battles, 11 countries get destroyed. And that's characteristic of what you might expect from a comet. It's difficult to explain in human terms.
Was King Arthur really a comet? It's an idea that requires quite a stretch of the imagination. But comets were often depicted as fiery swords. Perhaps the myths were created to help people interpret events in the sky that they couldn't otherwise explain. Whether you believe all the interpretations or not, there is no doubt that comets were the subject of deep superstition. The reason was simple. In times when the movement of the stars and planets was used to predict the future, the sudden appearance of something unusual was a dangerous omen.
In the medieval world, philosophers and astronomers thought that everything further away from us than the moon is was perfect. Out there, beyond the moon, nothing ever changed. And comets just don't look like that. Comets look like fiery signs moving across our sky. They were threats to the idea of a perfect, calm, orderly universe. Perhaps they were guided by God in order to send signs to humanity of God's purposes. When comets passed, astrologers almost automatically predicted great transformation, the death of kings, war, invasion, plague, or famine.
Not everyone viewed them with foreboding. Genghis Khan saw comets as a personal message, telling him to fulfill his destiny and wage war across Asia and Europe. To William the Conqueror, the appearance of a comet in 1066 was such an auspicious sign that it was immortalized on the Bayeux tapestry. But for the Saxons, the comet was definitely a harbinger of doom. For centuries, all explanations of comets relied on superstition and astrology. It finally took the greatest mind of them all to make scientific sense of them. In 1680, a particularly bright comet caught the attention of Isaac Newton. It was a fascination that was to change the way we understand the universe.
On November the 19th, at 4:30 in the morning, in Cambridge, the comet was seen by some young man. And on the same day, at 5 in the morning, at Boston, in New England, the comet was also observed. What was extraordinary about this comet was that it was visible in the sky. It was very bright. You could see it in October and November of 1680, and then it disappeared behind the sun. And then another comet appeared from behind the sun in December, at the end of the year, and was visible right through to March of 1681. So the big question is this one comet or two? If it's one comet, then it's bent a lot near the sun. Now here's a diagram that Newton himself made of the path of the comet if it's one comet. You see here that it was approaching the orbit of the Earth and the Sun in October and November of 1680. And then it disappears behind the Sun and reappeared in December, and it stayed visible through February and March of 1681.
For the sun to bend the path of a comet this much, Newton realized that there had to be an unseen force at work. He called it gravity. An idea which didn't come from an apple falling from a tree, but from a comet passing behind the sun.
It was by thinking about this puzzle that Newton began to formulate the idea of gravitation. before 1681, Newton had no notion of universal gravitation. Newton, between 1681 and 1684, began to suppose that comets come back, that they're therefore like planets because they move in closed orbits, that you should be able to calculate the shape of the orbit, that you could in fact predict when comets come back.
And that is exactly what he and his friend Edmund Halley set out to do. If they could use the theory of gravitation to predict the return of a comet, they would not only prove Newton's theory, but would also show that comets were not omens or supernatural signs, but predictable orbiting bodies, like the planets. Halley collated tables of all the comet observations he could find, looking for similarities in their behavior, what direction they came from, how close they got to the sun. At last, he found 3 comets whose descriptions were almost identical. One recorded in 1531, one in 1607, and one he had observed himself in 1682. Each appearance was separated by 75 years. Convinced that these 3 sightings were of the same comet, Halley made a public prediction that it would return again in late 1758 or early 1759. It was an extraordinary piece of scientific bravado for the time. Neither Newton nor Halley lived to see the prediction fulfilled. But when, on Boxing Day 1758, a comet was spotted in Germany, it was greeted with jubilation and as a triumph of science over the supernatural. Tracing back through the historical records, Comet Halley could be found reappearing like clockwork. This Babylonian tablet records its appearance in 164 BC. The comets that Genghis Khan and William the Conqueror saw weren't messengers from God, but the regular appearances of Comet Halley.
A once-in-a-lifetime meeting tonight, live on BBC One. After its latest visit to Earth, Halley's comet is already on course back towards the icy wastes of outer space. In an attempt to...
The last time it visited, in 1986, it was greeted like an old friend. Around the world, people were transfixed as the probe Giotto beamed back the first live pictures of a comet nucleus. It was the last we'll see of Comet Halley until 2061. Perhaps the most surprising thing about comets is that 300 years after Newton and Halley, despite all that we now know about them, comets still have the power to capture and control people's imaginations. In 1997, a bright comet called Hale-Bopp suddenly appeared in the skies. It captivated skywatchers around the world. It was particularly keenly watched by a cult in California known as Heaven's Gate. They believed that the comet was concealing a spaceship that had come to take them to another, better world.
At this point, this is considered a mass suicide investigation.
So deep was their conviction that as the comet came closest to the Earth, all 39 members poisoned themselves, believing that in taking their own lives, they would free their souls to board the spaceship. It seems no matter how far science progresses, comets can still hold the power of life and death. What is true, as we are now discovering scientifically, is that comets have had a profound effect on life on Earth. One of the reasons they retain so much power over us is that they seem to appear out of nowhere. On the island of La Palma in the Canaries, Alan Fitzsimmons is trying to unlock the comet's secrets.
Here we have the William Herschel telescope, 4.2 metres of astronomical loveliness, all ready and waiting to spot a few of these comets.
It may seem odd to use such a powerful telescope to observe comets, the brightest objects in the night sky. But the scientists want to study the comet's nucleus, and to do that, they must see them before they start producing their tails, when they are further away than Jupiter. The nucleus is tiny, just a few kilometers across, and in the vastness of space, they are incredibly difficult to spot.
They only reflect on average 4% of the light that hits them, and a piece of coal reflects 8% of the light that hits it. So a comet nucleus is twice as dark as a lump of coal. And so we're trying to see these things from the feeble amount of sunlight they reflect out beyond Jupiter. It's not an easy thing to try and attempt to do. Oh my God. That's it. Yeah, that's it. Ha ha! Oh, fantastic stuff. Yep, yep, another one in the bag. Happy days. I do love this job, you know.
This tiny moving blob of light is the comet's nucleus, a delicate lump of rock and ice floating slowly through space. The most powerful telescopes pick them up as they drift through the outer planets. But their orbits suggest they come from much further into space, far beyond the realm of the planets. Finding exactly where they come from hasn't been easy. Since the 1940s, astronomers have been looking for a huge reservoir of comets, called the Kuiper Belt, which they believed lay beyond Neptune. The only problem was, no one could find it. No matter how hard they looked, the only object anyone could see out there was the ex-planet Pluto. By the end of the 1980s, almost everyone had given up looking, apart from two maverick astronomers on Hawaii.
I don't intentionally do things that are different, but I do try to be skeptical of everything, because I think that's essential for science. So if you just buy into the prevailing wisdom, then all you can ever do is confirm what's already known.
In 1987, Dave Jewett and Jane Liu set up at the Mauna Kea Observatory in Hawaii to stare into empty space, using up precious telescope time, finding nothing at all.
At first I couldn't get money to support any of this, because it seemed, I guess, so speculative or so crazy, and so instead I used money from other sources, probably illegally.
Everyone, even their colleagues, thought they were mad.
They started asking, oh, well, when are you going to stop? You know, you've been doing it for years now, you still haven't found anything, or maybe there isn't anything out there.
Eventually, their bloody-minded persistence paid off. After 5 years and over 400 hours observing, there was a small, moving anomaly on one of their pictures.
He said, "Jane, come take a look at this." And we saw something, and it was moving at about the right speed. We would expect a distant solar system object would move.
So we're instantly pretty excited about that because we hadn't seen any other candidate object so good.
It was just the first positive sign that we got after 5 years.
This was it. At last, they'd found the first Kuiper Belt object. They named it, catchily, 1992 QB1. Since then, over 1,000 Kuiper Belt objects have been found, quietly orbiting in the dark reaches beyond Neptune. But there are thought to be as many as 6 billion potential comets here, orbiting in a belt 3 billion kilometers wide. Occasionally, they collide. And one is sent tumbling into the inner solar system to become what we call a short-period comet.
Short-period comets orbit the Sun frequently, and their orbital paths bring them back around the Sun perhaps once every 10 or 20 years or so. And these are the objects that we believe have come from this trans-Neptunian region just beyond the realm of the giant planets.
Comet Halley is the most famous of the short-period comets. But there is another sort of comet, one whose orbit can be thousands or even millions of years long. They come from far beyond the Kuiper Belt, from an almost mythical place called the Oort cloud.
The long-period comets, as the name suggests, take a really long time to go around the Sun, perhaps anywhere between 200 years and 1,000,000 years to go around once. And these are the objects that tell us that the Oort cloud exists, stretching out tremendous distances towards the nearest stars.
This is the very edge of the solar system, halfway to the nearest star, 50,000 times further from the Sun than the Earth. Here, trillions of comets cling tenuously to the Sun's gravity. We now think that the Oort cloud was formed during the violent formation of the solar system. As the planets formed and their gravity increased, they catapulted chunks of debris into space. Some of it collected in the Oort cloud, where it has been ever since.
They've been out there in deep freeze, in deep space. And so by studying comets, we're studying the formation and the evolution of our solar system.
But studying the comets isn't easy. The Oort cloud is so far away, and the object in it so tiny, that we'll never be able to see it. But luckily for the astronomers, sometimes something happens that sends them tumbling towards us.
Oort cloud objects become comets not through the action of anything to do with our Sun, but through the action of other stars generally. Our Sun is just one of 100,000 million stars that form our Milky Way galaxy, the Milky Way that you can see on a clear, dark, moonless night. And they're all moving in slightly different directions with slightly different velocities, and occasionally a star will come close to enough to our Oort cloud that it will perturb some of those comets out there. Some of them will be thrown out into interstellar space, never to return. But some fraction of them will be nudged inwards into our solar system. Until recently, it was assumed that our solar system was isolated from the rest of space by the vast distances surrounding it. It's because we see comets that we now know what happens around the Earth.
is driven by the movement of distant stars.
This is one of the great discoveries of the last 20 years. Astronomers as a whole have increasingly begun to recognize that the solar system, not just the Earth, but the solar system, is open to its galactic environment. And that's a very important change of mindset than our ancestors, even our parents, probably had. Comets coming from the Oort cloud are bringing with them a message from outer space, quite literally.
Once pushed out from the Oort cloud, these long-period comets start the 2 light-year journey towards the Sun. They drift through space, silently and unseen, for tens, even hundreds of thousands of years. But as they pass Jupiter, just 400 million miles away, they light up and start to produce their tails. All of a sudden, we can see them. And we can also reach them. A number of missions have been sent to investigate comets at close quarters. The probe Deep Impact was sent to rendezvous with the comet Tempel 1, testing its strength and density by crashing into it. The Stardust mission flew past the comet Wild 2, capturing grains of dust from its tail that it brought back to Earth.
Okay, we have confirmation of the main chute.
Confirmation. Okay.
All stations, main chute is open. We're coming down slowly.
These bits of dust have been unchanged since the formation of the solar system and can tell us exactly what comets are made of. Perhaps surprisingly, the basic building blocks of comets aren't at all exotic. In fact, they're remarkably mundane.
I'm going to show you a really neat demonstration of how to make a cometary nucleus using some relatively simple things. Many of these things you can actually find in the average house. To start with, I'll add some water. The second major constituent of a comet is the dark organic materials, the rubble and the crud and so on. And to replicate that, I've got some soil. We also need to think about other ingredients that are in there. There are quite complex chemicals, organic chemicals. We can replicate that by putting in soy sauce. Now, of course, no one's suggesting there's actually soy sauce in a comet, but again, it's a really nice analogue for it. So I'll give it a good glug there, rather more than you'd use in the average dish. We can add a little ammonia, and ammonia in this case is in these smelling salts. Just bash a few crystals of that in. What it really does, more than anything, is just make the comet a little smellier. There we go. Now, the other ingredient we're going to add into this comet is carbon dioxide, or what you more commonly know as dry ice. You get a fairly violent reaction because the dry ice is meeting water, which is about 80 or probably 100 degrees warmer. You can see the carbon dioxide turn into gas. Let's give that a good squeeze and see how we're doing. It's really bubbling away violently now. And that looks good.
This dirty snowball is a surprisingly accurate model of a comet nucleus. And as it warms up, it starts to behave exactly as a real comet does. It produces a tail.
You can see a beautiful, one of the best I've seen actually in doing this one, a beautiful jet coming out here. And that's exactly what happens when a cometary nucleus gets near the sun. Near the surface particularly, you see ice turning to gas. It doesn't turn to liquid because there's no pressure in space to allow it to exist as a liquid. And so the frozen carbon dioxide, the frozen water, the other chemicals in a comet become gas-like and they jet out.
In the vacuum of space, the escaping gas blows dust from the surface, and the debris builds up into a vast halo called the coma. A single comet nucleus can produce a coma over 1 million kilometers across, bigger than the Sun. It would expand forever if it wasn't for the pressure waves emitted from the Sun that shape the coma into the comet's dramatic twin tails, one made of dust and one made of gas. Which is why, no matter what direction the comet is traveling, the tails always point away from the Sun. The longest tails can be 500 million kilometers long and stretch halfway across the solar system. It's a grand display, one of the greatest shows in the universe, though it is a sign that after 4 billion years, the comet is dying.
The fact that we see them now as active comets means that they have only a few thousand years left in their current orbits. So you can imagine if you liken that to the lifetime of a human being, we're seeing the last few seconds of the lifetime of the comet.
Every second, they are losing tons of dust and ice. Each time it goes round the Sun, the comet nucleus shrinks. Most have only enough fuel for 1,000 revolutions round the Sun. Even a large comet like Halley will only last another 150,000 years. And then, as their fuel supplies are exhausted, they die. Some perish as they crash into the Sun. And some disintegrate, eventually turning into dust. Dust we see as shooting stars as they enter the atmosphere. But not all of them disintegrate to dust. Some of them leave a more substantial skeleton drifting through space.
We predict there should be hundreds or maybe even thousands of dead comets which still haven't yet been found. If the comet fades to dust and nothing else, then in a way they're not dangerous. But on the other hand, if they leave behind big chunks, hundreds of meters across possibly, then those objects could come through the atmosphere with some devastating consequences on the ground.
Is the Earth really in danger from comets? Although big, they are incredibly fragile, no more substantial than cigarette ash. Still, some think a comparatively small chunk of comet could cause a global catastrophe. Mike Bailey is a paleoecologist who's found the evidence of an ecological disaster in the fields of Northern Ireland.
20-odd years ago, the farmer, when this field was being drained, found that these oaks were effectively floating to the surface. The land was shrinking round them. So he got a digger in, pulled them out and pushed them into a heap. And in a flat area like this, it's a handy windbreak for sheltering animals, so the farmers leave them, and it means that we have access to some ancient trees.
Some of these oaks are thousands of years old, preserved perfectly in the oxygen-free conditions of the Irish peat bogs. By sampling tens of thousands of trees, Professor Bailey has built a year-by-year record of the Irish environment for the past 7,500 years. What he has found encoded in the annual rings is that the trees sometimes mysteriously stopped growing.
this tree went from a period of extended, perfectly good, what we would regard as normal growth. When we get to this year, which is the year 540, there's a damaged scar, and its growth was radically changed in character thereafter.
When the same pattern emerged in many of the Irish trees, it was initially dismissed as the effects of a savage storm that struck Ireland in 540.
What caused a complete turnaround in this story was when we found that this same dated event occurs from Mongolia, Siberia, northern Sweden, across northern Europe, North America and South America. This was the realization that this was a global event.
Here was evidence of a worldwide catastrophe in 540 AD. What could have caused such a widespread disaster? There was one obvious suspect. The biggest volcanic eruptions blast so much ash into the upper atmosphere that it spreads around the world, blocking out the sun's rays. The eruption of Mount Pinatubo in 1991 caused global temperatures to fall by over 0.5 degrees for the next 2 years. It's the same pattern that is seen in the 540 event. But volcanic eruptions also leave another trace. A layer of sulfuric acid that is frozen into the Greenland ice sheets. But the samples taken from deep within the ice show no acid spike in 540. Whatever stopped the trees growing, it wasn't a volcano.
If you have a global environmental event and it wasn't caused by a volcano, what's the next most likely explanation? And you're allowed to ask the question, could it have been some sort of loading from space? Could it be an extraterrestrial event? And as soon as you start even asking that question, you realize that the most likely sort of event you would be talking about would be some sort of brush with a comet.
In theory, a lump of comet just 300 meters across could affect the global climate. As it hit the atmosphere at over 20,000 kilometers an hour, it would burst into flame and blow itself to bits while still kilometers above the ground, spreading a shroud of dust around the world that could block out the sun. It's an event they call an airburst. And there is much more recent evidence that suggests these events do happen. On June the 30th, 1908, a huge explosion tore through the forests of Tunguska, Siberia. No one witnessed the explosion itself. But it threw up clouds of dust that reflected so much light, they could be seen as far away as London.
It was so bright, so the story goes, people were able to play cricket at midnight and people were able to read newsprint. That gives you an idea of how much dust must have been liberated very, very high into the atmosphere, which was illuminating the ground even as far away as London is from where the impact actually happened.
It was 20 years before the Russians mounted an expedition to the site. What they found astounded them. "60 million trees across an area the size of London had been leveled." Puzzled, the Russian scientists performed a set of experiments to try and figure out what could have caused such devastation. The only explanation was that the explosion was caused by an extraterrestrial object just 60 meters across, running into the upper atmosphere. This was just a small airburst, but it showed the amount of damage that could be done.
All that energy of motion is converted into heat, and it's just like the explosion of a nuclear weapon in the Earth's atmosphere.
One can only imagine the effects if an airburst exploded over a populated area. If this is the devastation comets can cause, perhaps our ancestors had good reason to be afraid of them.
The comet called Shoemaker-Levy, photographed
about to smash into the planet Jupiter.
Preparations for what could be the most dramatic astronomical event of the century.
When the comet pieces strike Jupiter, it will be the most massive collision of celestial
crash into the planet with the force of millions of nuclear weapons.
If anyone was left in any doubt of the true destructive power of comets, an event in 1994 would change their minds. It happened 400 million miles away, but in solar system terms, it was in our backyard. Comet Shoemaker-Levy 9 was discovered in 1993. It had been torn into 21 separate pieces by the gravity of the planet Jupiter, creating a line of debris known as the String of Pearls that was on a collision course with the giant planet. This was a unique astronomical event. No one had witnessed two solar system objects collide before. As the scientists planned their observations, less rational comet fever took hold once more.
At the time of the comet impact, we may see the biofield around people change. Some people will feel excited, some may feel more depressed, we don't know.
We have a piece of software that tells us what the comet's impact will mean for you as an individual.
So is it going to happen to me on that date, the 16th?
Maybe discard some old ways that were holding you back.
July 16th, I should beware, right?
Yeah.
No one knew what effect, if any, the comet fragments, just a few kilometers across, would have on such a huge planet. As the comets approached, the world's astronomers watched the pictures coming in and held their breath.
It's right in the middle. That's amazing. Look!
Yeah, that's
oh
it.
My God.
That's it.
Look at that. Look at that.
The scale of the explosions surprised everyone.
Okay, we just blew up a section of the planet. This is the southern pole here. You see there's a bright streak. See that bright streak? And around the edge of the streak there's some other stuff. It was not there the day before. It's a new feature on Jupiter.
As the comet struck the Jovian atmosphere, fireballs 3,000 kilometers high erupted from the surface of the planet. The biggest impact released 600 times more energy than the entire world's nuclear arsenal. Scars bigger than the Earth were left on the surface of Jupiter. These were some of the biggest explosions that had ever been witnessed.
It delivered. How about it?
Perhaps this was not the right time to celebrate. The Jupiter collision showed the enormous power that could be released by a full-blown impact with a comet. Just imagine if it had hit the Earth. it's not just fantasy. Impacts this size have happened to the Earth. The last time was 65 million years ago. It spelled the end of the dinosaurs and wiped out half of the rest of the species on the planet. Awakened to the danger, we now have projects to scan the skies, looking for objects that are a threat to the Earth. But most of the sky surveys concentrate on finding asteroids. Unlike comets, which originate in deep space, asteroids mostly come from the belt between Mars and Jupiter, from where they are periodically deflected into an orbit that crosses the Earth's. But these rogue asteroids are easy to spot, and their trajectories can be plotted hundreds of years into the future. Giving scientists plenty of time to devise ways to divert them, so they miss us. Unfortunately, avoiding an incoming comet would be a very different proposition.
Comet impacts are likely to be more rare than asteroid impacts, but they're going to be much harder to mitigate against, because a comet will be coming in from deep space, will have a few years at best, a few months at worst, knowledge before impact. And that may not be time enough to launch a spacecraft to deflect the orbit.
People might remember a few years ago we had a fantastic comet called Comet Hale-Bopp. Suddenly came out of nowhere. It's about 3,000 years since it had last passed by. And that was a very bright comet, and suddenly it was there in our midst. We've had recently a comet called Comet McNaught, which was a comet you could see with the naked eye. Nobody had predicted the appearance of these comets. You might get 2, 3, maybe 6 months' notice. So it's possible that there could be a catastrophic collision with the Earth any time.
It's a scary prospect, but perhaps not one to keep you awake at night. It's estimated that the Earth will endure a Tunguska-sized impact that could destroy a city once every 1,000 years. And an extinction-level event, like the one that wiped out the dinosaurs, every 100 million years. And rather than being afraid of comet impacts, perhaps we should be grateful for them. They might be responsible for us being here at all. Way back at the beginning of the solar system, the planets were formed from the disk of debris that the early sun had thrown out around it. As the disk was stirred, bits of dust stuck together and became boulders. Boulders stuck together and made asteroids, which stuck into larger clumps that became the planets. It was a hot, violent process, and when it was finished, it left the Earth a barren and sterile place. Yet within a few 100 million years, the Earth was covered in oceans, and life was thriving. Where can it all have come from? There is only one obvious source of water and organic molecules in the solar system: comets. But to explain how the Earth was transformed from a sterile boulder into the blue planet, astronomers have had to propose a massive hailstorm of comets 3.8 billion years ago, They call it the Late Heavy Bombardment.
The solar system wasn't as we see it today. There was still a lot of the stuff left over, the builder's rubble from the building of the planets. And Jupiter and all the other gas giants out there were doing a very good job at throwing stuff inwards towards the sun. Some of which, unfortunately, we got in the way of, or rather, I should say, fortunately for us, if they really did bring the water that we see today. We're talking about a bombardment of the, if you like, the proto-Earth. That takes millions or tens of millions of years with an impact rate that may have been 1,000 or 10,000 times what it is today.
The bombardment hasn't finished. It's still going on today. We're not quite so aware of it because that bombardment is by tiny, tiny dust particles that float down through the atmosphere every day. About 60,000 tonnes over the whole of the Earth every year. Comes down as dust particles. Water is bound into those mineral grains. So we're still being bombarded by grains that carry water and carbon, even today.
It's an amazing thought that all the water and all the organic molecules that make up every living thing on the planet may have started out on a comet beyond the edge of the solar system. But there are people who have taken the idea even further. They believe that comets brought actual living creatures to the Earth.
Earth life is essentially alien life. It is not a life that was indigenous to the Earth by any means. And if we evolved from that life, then I think we are the products of evolution from alien life.
In the 1960s, astronomers Fred Hoyle and Chandra Vikramasinghe proposed that the Earth was colonized by bacteria from outer space. It was an idea called panspermia, and it's never quite gone away.
I think it's true to say, isn't it, that if your theory is correct, life not only may be spread throughout the universe, it must be.
It would really be very surprising if life is not, if the galaxy is not just teeming with life.
Since then, there have been a number of strange discoveries that may, or may not, back up the theory. In 2001, the southern Indian state of Kerala was shocked by a loud explosion, followed by storms of blood-red rain over the next 2 months. Local scientist Dr. Godfrey Lewis collected samples from all over the state and analysed them. What he found was that the rain was being turned red by cells the like of which he had never seen before.
It's quite exciting to see this. They look like red blood cells, but they are not, because this is having a very thick cell wall, and that cell wall is not there in blood cells.
What made the cells even more mysterious was that he could find no trace of DNA in them. If that was the case, the cells were like nothing else on Earth.
The staggering claim is that this is possibly extraterrestrial. That's a big claim, I know. But all the experiments are supporting this claim. Coming from Chandra. This is some of the samples we have collected.
Right.
It's a pretty good sample we have. You can see the...
So this is the real stuff, man.
Yeah, this is the real stuff.
It's red for sure.
Yeah.
And they all...
For Chandra Vikramasinghe, this was vital evidence to back up his theory. a fragment of comet must have blown up in the upper atmosphere and rained extraterrestrial bacteria down on the Earth.
If it is true that these are alien bugs from space, then it is an absolute clear-cut proof of panspermia, ongoing panspermia. And that would be absolutely fascinating, and I'd be over the moon.
But unfortunately for Vikramasinghe, there was bad news. On closer inspection, the cells in the red rain didn't seem so alien after all.
This is DNA from the red rain.
Wow, there's no doubt about it.
There's no doubt about it.
It's absolutely conclusive as far as I can see.
The material, when examined by astrophysicists and people who are looking for evidence to support a view, doesn't appear to be anything that they've ever seen before. But people who actually have seen things before say, looks like red algae to me. I would tend to go with the people who have seen more things in the biological kingdom rather than those who are looking to support their own ideas about how the world should work without the data to back it up.
The journey towards the truth is always a rewarding one, I think, and I saw this as a journey towards discovering a truth that was quite plain to me, and is becoming plainer and plainer to other people now, after 30-odd years.
Whatever their actual role, it seems comets were vital in the evolution of life on Earth. And they maintain the ability to destroy it. It seems our ancestors were right all along. Comets do carry the power of the gods. Maybe that is why they still cause so much excitement when they appear in the sky. What's more, when astronomers turn their telescopes to other stars, they see clouds of dust, the telltale signs of comet activity. Just as comets helped bring life to our solar system, they may be doing the same elsewhere. Perhaps that is the next message that comets will bring us, that we are not alone.